Hey folks, how's it going? This is Mr. Murray coming to you with a do now for Course 1 CP for April 6, 2020. So in this video, what we're going to do is we're going to kind of start to, again, talk about the ideas behind graphing functions. And we're going to take a step back and just really make sure we polish up our skills with standard form. Okay, so if you didn't notice, this is a quadratic function based on the x squared. And this is standard form, okay? And so what we're going to do is we're going to make a table and a graph fitting as many points as you can on there. There should only be, I believe, 5 points that'll fit on there, including the vertex. And this is because we're talking about one of our main concepts this year, which is functions, different types of functions and their graphs, right? So we started with linear functions when we talk and sequences and such. We got into piecewise functions. We got into absolute value functions. Ordinarily, we would have done exponential functions after that. And now we're talking about quadratic functions. So all different kinds of functions and their similarities and differences. So here's what I want you to do. Again, I want you to create a table and build a graph. So pause your video, make that table and graph, and then when you're ready, unpause, and I'll show you how to solve it. Okay, here we go. So what I'm going to do is I'm going to try to plug in 0 first, because I think 0 is the easiest number to plug in. And all you're doing is plugging in for x and seeing what comes out. So I do 0 squared is 0. 0 times 3 is 0. Remember, you can also find the vertex using the formula negative b, x equals negative b over 2a. Okay, so you've got 0, 0. And actually, if you do negative, well, look, there is no b, right? Because standard form looks like this. Ax squared plus bx plus c. Now, look, we don't have a b. We don't have a c, right? All we have is an a. So if I do negative b over 2a, it's literally negative 0 over 2 times 3. So it's like literally negative 0 over 6, right? That's 0. So it tells us the x of the vertex is 0, and the y of the vertex is, what you get when you plug in 0, which is 0. Now I'm going to try 1. Let's see what happens when you plug in 1. So 1 squared is 1. 1 times 3 is 3. Let's plug in 2. Okay. 2 squared is 4. 4 times 3. See, already, like, not even going to work. We're way off the graph. Okay, way off the graph. Okay. So I'm done. I'm not gonna go to 3, right? Because look, if I plug in 3, you get 27, right? That no way that's fitting on the graph. So don't even worry about that at this point. What about negative 1? Well, if you know the vertex, the x of the vertex is 0, then based on the symmetry, you should also get 3. Otherwise, if you plug in, negative 1 squared is also 1, because it's negative 1 times negative 1. And then you multiply by 3, and you get 3. And then negative 2 will have the same output as positive 2. And if you notice, negative 2 times negative 2, that's 4, right? Just like 2 times 2 is 4. So you get the same output. So here's what we got. And if I'm going to do a little guesstimation there, okay, it's very narrow. And if I compare this to the parent function, 0, 0, 1, 1, 2, 4, 3, 9, and with the negatives as well, okay, you can see this graph, the purple graph, is a lot narrower than that of the parent function, and that's because it's tough to see here, but this 3 is multiplying the y values by 3, therefore making them a lot bigger, therefore stretching them up. It's taking the graph, you can imagine taking it, grabbing it by those arrows, and pulling it up. Okay, and I'm making the hand gesture. Obviously, you can't see because you can't see me, but that's the idea. All right, so today, again, please check the lesson notes on the Google Doc. If you can't get to the Google Doc, go to we.willnot.fail and select your class or log in, and your class will automatically come up. And, check out the worksheet for today. We're doing the front side only. Keep it up. Don't forget to love math. And remember, You can do it. All right, thanks for watching. Have a wonderful day. I'll see you back here tomorrow.